Life is not limited by what we imagine possible, but by what conditions allow. Charles Darwin. Please watch to the end. The most interesting part is at the very end. Pectinodonta orientalis is a species of deep-sea limpet belonging to the family Pectinodontidae, a group specialized for life in extreme environments. This mollusk is typically found on hydrothermal vent fields, where temperatures, chemistry, and pressure would kill most shallow-water organisms. Unlike coastal limpets that graze on algae, Pectinodonta orientalis lives in total darkness, thousands of meters below the surface. There is no sunlight, no photosynthesis, and no traditional food web. Instead, life here is built on chemosynthesis, energy derived from chemical reactions involving sulfur-rich vent fluids. The shell of Pectinodonta orientalis is relatively thin but mechanically efficient. It allows the animal to stay tightly attached to hard substrates such as basalt or sulfide chimneys, resisting strong vent currents and sudden temperature fluctuations. This attachment is critical for survival in unstable vent habitats. In nature, nothing exists alone. Rachel Carson. The limpet feeds primarily by grazing on microbial biofilms that coat vent rocks. These biofilms are dominated by bacteria that use sulfur and methane as energy sources. By consuming them, Pectinodonta orientalis becomes a direct link between microbial primary producers and higher levels of the vent ecosystem. Its radula, the rasping tongue used for feeding, is adapted for scraping hard mineral surfaces. Exclusive biological detail. Studies of vent limpets show that the radular teeth in this group incorporate metal-enriched compounds, increasing wear resistance when grazing on mineral-crusted rocks. This is rarely mentioned outside technical literature and is absent from most general descriptions. Reproduction in Pectinodonta orientalis follows a strategy common to deep-sea mollusks, broadcast spawning with larvae capable of dispersing through deep currents. This allows the species to colonize new vent systems, which are geologically short-lived and can disappear within decades. Hydrothermal vents are not permanent habitats. They form, shift, and collapse. Species like Pectinodonta orientalis survive not by stability, but by adaptation and mobility at the larval stage. The history of life is a history of adaptation. Stephen J. Good. This limpet is a clear example of how evolution shapes organisms not toward comfort, but toward efficiency under pressure, literal and biological. If you watch to the end, you now understand why Pectinodonta orientalis is not just a mollusk, but a biological solution to one of the harshest environments on Earth. Support the channel. Like the video, subscribe, share it, and write in the comments which deep-sea species you want to explore next.